Okay, so in these problems, we're going to use the continuous exponential growth formula. I'm going to write it up here. It's the one with E. So it's A, which is the initial amount, times E, which is a number that's about 2.718. It goes on and on forever. It's an irrational number. You can use the button in your calculator, or you could just use 2.718 when you work it out. To the R is the rate, and it's usually written as a percent. We have to change it to a decimal, times T is the unit of time. Okay, so let's look at this first problem. Suppose $5,000 is put into an account. That means that's going to be our A, initial amount that we're starting with. That pays 4%, so that's going to be our R, that's the rate, compounded continuously. So the key word, continuously, means that's how we know we're using this formula, as opposed to the other formulas we know for interest. How much will be in the account after 3 years? So that's going to be our time. Okay, so I'm going to use A is 5,000. I'm going to write 5,000 times E, because it says compounded continuously, so we know we use this formula with E. I'm going to change the 4%. We don't write it as 4%. We want to write it just as a decimal form, so 0.04 times T, which is 3 years. R times T is the exponent. And then I just go ahead and type that into the calculator, and you should get 5,637 and 48 cents. Okay, we're going to do another problem. And this one has to do with population growth. So this is another example where the exponential growth is continuous. So population grows at a continuous rate. It's not really just stopping and then waiting until the end of a certain month or a certain unit of time to keep growing again. Population just grows at an exponential rate continuously. So since 2000, the population of parrots in a town has been following a continuous exponential growth model. So when you see the word continuous in the problem, that's how we know we're using this formula, with an annual rate of 10%. So that's going to be our R value. There are 500 parrots in 2010. About how many parrots were there in 2000? So it's asking us to go backwards and figure out the initial amount in 2000, because it says since 2000, that means the starting amount. And then we want to know when it's saying after 10 years that there are 500 parrots at the end. So I'm going to just put A as the initial amount, that's what we want to solve for, times E to the RT. So R, the rate, to write as a decimal, would be 0.1. And then T, the time, is 10 years. So it's saying we want to know the initial amount if the rate is 10% and it's 10 years later in 2010, and now there are 500 parrots. Okay, so basically what we want to do, I'm going to simplify this exponent. I'm going to write it as A times E to the 0.1 times 10 is just 1. So it's E to the first. And we want to solve for A, so that means we're going to divide both sides by E. In your calculator, you can type 500 divided by E. It might make you put in an exponent on the E and just put E to the first. And if you do that, you should get about 184. And what we want to do is just check to make sure that that makes sense. So I'm going to plug 184 back into the equation and see if we get 500. So when I go to the calculator and plug that back in, I get 500.2. It's about 500. So yes, it works. So my initial number of parrots is 184.